Hi everybody. Today we're going to take a look at series and parallel circuits. So I've drawn a circuit here on the page. A couple of things you should notice. The straight lines represent wires. The little zigzaggy guy here represents a resistor. Resistor is just something that slows down current moving through a wire. Other things that can be resistors could be a light bulb. A light bulb slows down current and gets hot and glows, and that's what gives us an incandescent light bulb. And this guy over here that I'm drawing an arrow to, that's the battery. The long side represents the positive side of the battery. The short side represents the negative side of the battery. Now, we should be able to trace a nice complete loop from the positive side of the battery all the way to the negative side of the battery. So if I start at the positive side and I trace, I can make one complete loop back to the negative side. We learned a couple of lessons ago that there's something called Ohm's law. There's an equation, V equals I times R. Voltage equals current times resistance. I is current, R is resistance. So I'll just write this in words. Voltage equals current times resistance. So let's say that our battery here was 12 volts and our resistor was 3 ohms. We could do 12 equals I times 3, and we find out that the current is 4, and we measured in amps, A. So that means this yellow line that we drew represents 4 amps of current going around our loop. Alright, let's take a look at another example. Very similar circuit, 12 volt battery. Now there's two resistors, one after the other. We say that these two resistors are in series with each other. What does that mean? Series means that when you draw your loop, the current goes through both of them. They both receive the exact same amount of current, because this yellow line has to pass through both resistors. Think of current as like water flowing through a river. Think of that kind of current. If there's two places along the river that the river's flowing past those same exact 2 points, it's the same current going past each. So they're both going to have the same amount of current. Now the resistance, they're going to add up. So we have a total amount of resistance here that's going to be the sum of 2 and 4. So it's really like we have 6 ohms of resistance. And a way that we show this oftentimes is with a table. So we'll do V, I, and R. And we've got two resistors, R1, R2, and we'll do a total column, or total row as well. So things we know there's a 12 volt battery total. We know R1 is 2 ohms and R2 is 4 ohms. Now, I just told you a minute ago that in series resistors add together. So that'd be 2 plus 4 gives you 6 ohms. Now the nice thing is we can use Ohm's law to figure out the total amount of current, this spot right here. Because we know V equals I times R. So 12 equals I times 6. Just pulling these two numbers. So divide by 6 and you get a current of 2 amps. Oops. That means if we were to label our highlighter, we've got 2 amps of current going through each resistor. Now, since that's total current, we have to have 2 amps going through R2 and R1. So this is all the same 2 amps. Lastly, we can do V equals IR. We can show that with our little times and equal symbols. 2 times 2 gives you 4. 4 times 2 gives you 8. And notice our voltage adds up. So at each resistor we could label everything. The current here is 2 amps, current here is 2 amps, and voltage we could label in green. 2 times 2 gives you 4 volts. 4 times 2 gives you 8 volts. Notice that adds up to the battery, 4 and 8 volts. So we've got a few rules that apply to series circuits. We've used them already. First rule is that the current in series is the same. If there's 2 resistors that are one after the other, or 3 resistors, or 4, or 5, or however many resistors are in series, they all have the same current. Rule number 2 in series is that resistance adds up. If you have a 1 ohm resistor in series with a 2 ohm resistor in series with a 3 ohm resistor, you would just add 1 plus 2 plus 3 to get the total resistance. And our third rule for series circuits is that the voltage adds up to the battery voltage. We saw that in our second example. We had 4 volts across R1, 8 volts across R2, 4 and 8 adds up to 12. On your homework for today, this will get you through number 1. Number 1 has 2 resistors that are in series with each other. Now let's take a look at a different kind of circuit. Drawn it here, we've got 12 volt battery, we've got 2 resistors, 20 ohms and 5 ohms. And we're going to again try and figure out the voltages, currents, and resistances everywhere. So we can fill in our table things we already know just off the diagram. 12 volts is the battery. I'll just leave off the labels for now, just 12. R1 is 20 ohms. R2 is 5 ohms. So those 3 numbers were already given. Now, just like before, we can trace out a complete path, a complete circuit. So starting at the positive side of the battery, I go around and I come to a fork in the road. I can either go left or right. What happens is some of the current goes this route and back to the battery. That's one complete loop. Other amount of the current picks a different route. It goes the other way. Okay. We have 2 paths, which means R1 and R2, since they come back together, are parallel to each other. They're not in series. Okay, yellow and red are 2 different paths. We have 2 parallel paths. Okay, another piece of information about parallel circuits. I guess we can get into the parallel rules here in a second, but parallel resistors, like R1 and R2, since they are parallel to the battery, they are both going to have the same voltage as the battery. So R1 and R2 are both going to have 12 volts of potential across them. That way, either loop, yellow or red, gets all 12 volts. Remember in our previous example, we wrote in green for the second example that we had 4 volts on the first resistor and 8 on the second. They add up to 12, so the one lap added up to 12 volts. Well, for parallel, either lap, yellow or red, has to add up to 12. So each one must be 12 by themselves. And then we can look at our V equals I times R to get the currents. So 20 divided by 12 is 0.6. I think I said that backwards. 12 divided by 20 is 0.6. 12 divided by 5 is 2.4. Those are our currents. Notice you get more current, 2.4 amps, through the lower resistance side. It's because the current is going to split up, and current is lazy. It tries to take the easiest path, or the most of it's going to take the easy path. So if it has a choice of going through R2 or R1, the majority of the current is going to go through R2 because it's the easier path. It has less resistance. So that's why you get more current through R2 than you do through R1. Now these 2 amounts of current, yellow and red, they come back together to go back to the negative side of the battery, which means we're going to add down this column of voltages, of currents, 0.6 and 2.4 adds up to 3 amps. And then we can do 12 equals 3 times R. So divide and you get 4 ohms as your total resistance. This example will help you with number 2 on your homework for today. And it's nice because it has all whole number answers, so you don't have to deal with any decimals. If you need help with this, either come to our team session or let me know in an email and I can give you some help.